Welcome to the SecurityX CAS-005 video, where we explore topic 1.4.6, modeling the applicability of threats to the organization or environment. This topic focuses on how we apply threat modeling in two real-world scenarios. 1, when a system already exists, and 2, when a system does not exist yet. Understanding how to apply threat models in both cases is essential to preventing security failures and improving the resilience of our IT environments. Let's begin with the first scenario. What happens when we already have a system in place? In this case, we are dealing with a live environment. It could be a web server, a cloud deployment, or an internal application running in production. Since the system already exists, our job is to model threats against what's currently operational. That includes identifying vulnerabilities, misconfigurations, or exposed assets. For example, imagine you manage an e-commerce website. It processes payments, stores customer data, and connects with third-party APIs. A realistic threat in this case might be a SQL injection attack targeting the login or checkout page. You perform threat modeling by identifying where inputs are taken and how queries are processed. You might use a method like attack trees to visualize how an attacker might exploit a vulnerability in the login form. You then decide on applying input validation, prepared statements, and a web application firewall. These are the appropriate controls that directly address the threat identified. In another example, let's say your company has a file-sharing platform with exposed ports that are accessible over the internet. Threat modeling might reveal the risk of unauthorized access or ransomware. Once again, the system is already live, and modeling the applicability of threats helps you understand where your controls are weak and what new protections are needed. In this scenario, selecting appropriate controls depends on knowing what's already implemented, what gaps exist, and how attackers are most likely to exploit them. Controls might include enabling logging and alerting, isolating critical services using segmentation, or hardening configurations. Now, let's switch gears and talk about the second scenario. What if the system does not exist yet? This is common during the planning and development phase of a new system. Here, threat modeling becomes a proactive exercise. The idea is to anticipate threats even before any code is written or infrastructure is deployed. This is where security by design comes into play. Imagine your organization is building a new mobile banking app. In the early design phase, you brainstorm possible abuse cases. One likely threat is a man-in-the-middle attack during user login. Even though the app isn't live yet, you can plan appropriate security controls like enforcing TLS, using certificate pinning, and encrypting data at rest and in transit. The benefit here is that you eliminate vulnerabilities before they ever reach production. In this case, you might use threat modeling methods like Stride or Pasta to analyze the system's design and identify potential attack vectors. Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. By going through each of these threat types, you can systematically evaluate how your design could be exploited and choose controls accordingly. For example, to prevent spoofing, you might require strong authentication. To prevent information disclosure, you might ensure data is encrypted. Because the system doesn't yet exist, you have the flexibility to build in security from the ground up. Let's also talk about how you choose the right controls. In both cases, with or without an existing system, control selection is key. The controls must be relevant to the threat, feasible to implement, and effective in your specific environment. They should also align with recognized frameworks, such as NIST, ISO, or CIS. The idea is to apply the right level of defense without over-engineering or overspending. To summarize, threat modeling is not one-size-fits-all. When the system already exists, you focus on patching vulnerabilities, closing gaps, and reducing attack surfaces using real data and system behavior. When the system is still in design, your job is to imagine how attackers might exploit future weaknesses and prevent them before they're ever introduced. Both approaches are essential to maintaining a strong security posture. One is reactive but necessary, and the other is proactive and cost-effective. Together, they help organizations stay ahead of threats and minimize risk across the board. That concludes our overview of topic 1.4.6. In the next video, we'll look at practical ways to integrate threat modeling into your security operations and development lifecycle. Thanks for watching and stay secure.